you think you know where to begin in your AI design, think again, because there are lots of questions that need to be addressed well before you even think about starting a design. Good afternoon and welcome to yet another edition of DevTalk with Rich and Vin. I am Rich Nass, the Executive Vice President of Open Systems Media, and down there in the bottom right corner is Vin D'Agostino, who is developer extraordinaire. I think I used that intro for you on multiple occasions. You have a better intro?
You keep changing my intro. I have to keep changing what I do for a living every time you introduce me. That's a problem.
Well, I don't even know what you do for a living, frankly. I just learned you're an actor on the side. What's up with that?
I mean, I studied when I lived in Boston. I actually did 2 terms of studying with Improv Boston. I actually should take improv classes. Not for the comedy aspect. Everyone is used to seeing things like whose line is it anyway, but the concepts that are used on stage when you are doing improv, listening while you're talking, the whole yes and thing, which suddenly became a big thing in business, really comes from that environment where when you're on stage with somebody else, if they say something, you can't negate what they said. You have to incorporate what they said in your thing. So if you and I walked out on stage and I thought we were in the kitchen and you thought we were on an airplane and you started out by saying, boy, these airplane seats are so uncomfortable. I can't say, what are you talking about? We're in the kitchen. I have to say, yeah, I told you not to do furniture shopping at the airline surplus store. I hate eating breakfast looking at the back of your chair. Right. So good. Suddenly I'm taking your stuff and incorporating it in where I wanted to, and you know, so much about business and coaching your employees and even developing.
I thought this was going to go down the route of when you have to talk to investors, you need to be able to.
Well, and there's investors for sure. You know, if you're in a startup or if you're in a public company, but
you don't need to know that anymore because now we have AI and that takes care of all of this, right?
It takes care of some of it. You know, I had a discussion with somebody the other day and I said, in your lifetime, you won't be replaced by AI, but you could easily be replaced by someone who knows how to use AI, right? And I think that is a significant distinction for the current generation of people.
So where are you with your AI developments these days?
You know, I'm working with a couple of customers who are actually trying to bring either AI itself or AI collaborations to market, and working with customers who are in the space of delivering product. And AI AI is the new smart something, right? Everybody has it as a marketing bullet and also as a technical feature. And you can have it as a marketing bullet, even if it doesn't do anything of value technically. But if you want it as a technical feature, you really need to understand it and how it's best deployed and utilized to really add value to the product or the service that you're providing, right?
See, now from a high level, that makes sense. But when you actually dive into it, this is where I think people struggle. It's like, okay, I know I need to work with AI. I'm pretty sure I know what it is, but where the heck do I start? And what is the first thing I do? And I actually had this conversation with Avijit Sinha of Wind River. And I said, you know, this is a really good conversation that we should have as a podcast, because I think our audience needs to understand that you need to be diving in at 1 and not at 6. Do you agree with that?
Yep, I totally agree with that. I would even say you need to dive in at 0. You need to look at your problem and see if there's a place that AI can help. There's not every place that AI can help, but if it can help, it can do it really well. If you are consolidating things that it would be impossible for you to consolidate on your own or in traditional ways, or if you're trying to predict something that you can't directly measure by triangulating other things that you can measure to make predictions, those are perfect applications for allowing AI to do its thing. Okay. You know, we talk about artificial intelligence. I don't encounter a lot of real intelligence sometimes in the world. So, you know, people just assume AI is going to fix everything, and it's not, but it can help if it's applied the right way and you understand it. So
why don't we bring up Avijit in and let's ask him where we start.
I was just going to say, we should talk to him about it.
Yep. How you doing, Avijit?
I'm doing good, Mitch.
So let me set the context first. You are the Senior Vice President for Strategy and Global Business Development at Wind River. Did I get that right?
That's right.
Okay, so you're lurking in the background, I assume, listening to our conversation and short of figuring out what kind of furniture we should buy. Are we on track with people don't really know where to start with an AI development?
Well, I think, first of all, thanks for having me. It's a great conversation to have. I do concur with a lot of what Vin said here. And what I'd say is that AI is a transformative technology for sure, but it's not a be-all, right? It's not a solution to everything. And we've got to be careful of the pattern of, I've got a hammer, so everything is a nail, right? The technology is very powerful, and it can enable people to do a lot of what they couldn't earlier do in a very efficient or productive manner. But we need to start with the problem that we are looking to solve, along the lines of what Vincent said, right? So there are two patterns that I at least use to try and determine whether the problem itself is ripe for applying AI. One, you need to work back from the customer. And second, you need to essentially do the jobs that needs to get done. So it's a Clayton.
Okay, let me interrupt you there because I want to make sure I understand. When you say work back from the customer, what do you mean by that?
To really see what it is that they are looking to achieve. What is the outcome that they want to achieve? What is the new product that they want to build? What is the business process that they want to optimize? What are the operational efficiencies that they want to gain? What productivity improvements they want to see? Or what new service are they looking to build? I think first understanding that and then understanding the value of that to the end customer and the business value to the business, and then exploring how best to solve that problem. And from that exercise, determining if AI is a good means of solving that problem. And from there, working on what aspects of AI are critical, and then what specific elements of AI. Is it a foundational model? Is it a deep neural network? Is it machine learning? And therefore, what data do you need? So there's a lot of thinking and analysis that needs to be done before one jumps to the conclusion that AI is actually the best technology or the tool to solve that problem. And I think that deliberate exercise of thinking through things all the way from what the problem is and decomposing that down to its base elements and using first principles, that is when you can truly harness the power of AI, when it is deployed in the right context with the right data for the right problem. Then it's very powerful. But if you just try to blanket use it and assume that it is artificial, generalized intelligence, that it is prescient and all-encompassing and contextually aware, that is not the state of AI today. It may very well be the case 10 years from now, but we've got to be clear on what it can do today and make sure that it is the right tool for the right problem.
Now, you said at the beginning, it's important people to understand what AI is and what it's not. I think I know what it is. What are you saying it is not?
Look, in fact, I think we should even talk about what it is before we talk about what it is not. What it is this. It is a technology that is able to reason on a lot of data using very significantly powerful computers or data center infrastructure to reason upon data and develop analysis, predictive capabilities, and the ability to essentially synthesize information and recommend a course of action, right? What it is not is it doesn't have as much reasoning capabilities. It doesn't have empathy. It doesn't have situational context, and that needs to be provided. And that is really what human beings actually excel at. Human beings have the ability to empathize with people, to reason, and bring to bear lots of information to the problem at hand. Information that might be 10,000 years old, or it might be 1 second old. And to be able to prioritize within that context as to what information to use to solve in that situational context. AI is not there yet. It can be built to get there for specific use cases and scenarios. So that is what it is in today. And that is what it is capable of doing. So that I think it's really important to have a good sensibility of its capabilities today, and what is well suited to solve, and what it doesn't, and what it can today, and it may be able to in the future. And that distinction is extremely important. Otherwise, we delude ourselves into one of two extremes. One, that it can solve world hunger, or on the other hand, it's going to come and destroy humanity. neither of which is true.
Yeah, and I want to also add, because I agree with everything that you said as well, is people need to understand that the conclusion that AI comes to in okay, I won't say 100% of the cases, but 99.9% of the cases is not a definitive answer. It is a prediction based on looking at multiple other things, right? So it is a game of probability and statistics with some reasonably high assurances in many cases. But it doesn't mean that it's absolutely the right answer and needs to be tempered somehow as well, right? And I think in the general population, people get excited about vision and sound and, oh, I can make myself sound like somebody else. I can, write a prompt in one paragraph and create a 3-second movie with characters that I want and the sound and scenes that I don't have to spend any money. And that's all exciting. But in the embedded space of the product development space, that's not the kind of AI that we're talking about. We're talking about resolving, in one case, let's say you're resolving 4 channels of streaming data to measure some things directly, that you can then triangulate that information to predict something about something that you can't measure directly, like the failure of a motor. There's no graph or no meter that you can put on a motor that says it's going to fail in 37 seconds. But if you're looking at temperature and pressure and vibration from that, and from the classifications of things that that are working well and not working well, you can make a prediction about the health of that motor and if it's getting near failure, right? So this is a fundamental difference in the way of thinking when you look at the results of something that AI has generated, right?
Okay, so now we know what it is and what it's not. Let's circle back to the original question. Where do I start?
Yeah, look, I think in terms of starting, there are 3 things I would say. Number one is understanding. So this is, I would say, education or skilling. The reality is that a lot of developers today were educated in and grew up with the notion of writing software in a software development lifecycle and essentially writing static code that gets compiled and then is dynamically executed. They learned a little bit of artificial intelligence and machine learning, but didn't really apply it. It's a very different way of developing software. So number one is, I think, education and skilling. Number two, then, is a real sensibility of what the capabilities of the tool are and are not, which is kind of what we talked about just now. And number three, I think, as we discussed earlier as well, is really employing it to solve real world problems and not hypothetical things or things that are fanciful of the nature that Vincent said. And that's all nice and good for a purpose of experimentation. But for the real world, where it needs to deliver real value, it is really important to have those 3 things. And I think in a business, as we look at what we do, not just Winterberg, but any other company, that is really what leaders are grappling with. Do I have the right skills? Do I have the right ability to distinguish between what to do and not to do, and what to use and what not to use? And then what problem am I really looking to solve? So I think that's the place to start. An executive needs to start with, what problems do I have that are well suited for AI? And then middle management and individuals in the organization need to start with, do I really know how to use this technology? And do I really know how to distinguish between what is good and what is not good, and what I can use and what I cannot use, and where it can cause predictable outcomes that derive benefits versus where it can cause unpredictable outcomes and can cause harm. And we can get later into the discussion around explainability and traceability. We can get into the discussion around safety, security, reliability, and performance. We can get into the discussion around AI for good and harm to society, privacy, and security. There are a lot of these aspects, and I think a lot of people don't spend a lot of time thinking about that. Even policymakers are starting to come around to understanding how to really create a regulatory and privacy framework to make sure that at a societal level, there is guidance available on how to really, leverage this technology, but do it in a responsible manner. So there's a lot there to unpack, by the way.
Yeah, I think I want to go one more step, though. Our audience very often is told what to do, like all the things you described, that the things that they are required to do, and then their management says, this is what we need you to do. These are all the things we need you to measure. These are the outcomes. Build me one of those. So what's that next step? Which I guess I'm thinking is the first step, but it's actually the second step.
Yeah, look, I mean, I'll come back to that number one point I made, which is, first of all, folks need to be investing time just getting hands-on with this technology, depending on whatever function they are in the organization. To your point, Rich, developers generally need to be using Copilot and data to see the code generative capabilities and see where it's able to, automate routine tasks that are not very exciting to a developer, that are not around the notion of creativity, documenting code, things of that nature, right? And then how do you use it to help you diagnose problems better? So I think it really comes down to that. I think we are at that stage where people need to really start experimenting with these technologies, whether it's GitHub Copilot or Amazon Q or it's Amazon SageMaker or OpenAI or ChatGPT, and different functions in different ways have to start using this in order to really get a sense of what it can or cannot do and what they can use it for, and what they can't, and where it's hallucinating, and their subject matter expertise can help them tease out whether what it is recommending or proposing is even real and applicable or not. So I think that's the place to start. Now, whether this is done through individual self-driven education or it's done through a systemic program at a company where a company takes out 2 months of time and says all employees are going to go through AI education and training, and it is fine-tuned to the job function, it could be done that way too. But it has to start with that. I think a lot of fear is coming from the fact that people really fundamentally don't have understanding of what the technology can do, and they have not used it. And so there's a sense of fear. And I think, as Vincent said, there's a lot of stuff in the popular media that causes people to, so to speak, believe things that are really not true and are not very grounded in where the reality is with the state of the technology.
As a member of the media, should I take offense to that?
You could or you couldn't. You're a member of the media, but you are in a subculture of engineering where, there's a lot of. We started out talking about yes and no but. Engineers are really good at saying no but, right? And I think this is one of those what I would call bridging technologies in the history of product development, where engineers may look at a marketing person and say, we don't need AI for this. And the marketing person will say, we need it for the business because we need to say we have it. So instead of saying no, but if the engineer said, yes, and let's work together to figure out what market problem we can solve with this. Now you asked me earlier what I really do for a living. So a big part of the business is doing this market technology mapping, where I work with a customer to look at their market and see what problems they're trying to solve and what technology they can incorporate to best address that problem with a good value proposition. AI is one of those opportunities. If engineering and marketing and management get together and say, here's a market we're in, here's a problem that has not been solved well historically, is this a place where we can apply this technology? That's when I said, go back to step 0, not even step 1. Look at the reason why you exist in the market, what problems you're trying to solve for your customers, what their needs are, and see if there's a way to take this new technology and map it to solve some of those problems and meet some of those needs. Now you've got a yes and approach to incorporating this, where the marketing person can put the bullet on, the CEO can talk to the stock market and investors, or the CFO, and the engineer can be proud about what they're working on. Right? This is one of those points of inflection where business collaboration within the company will make or break this solution and this deployment of this technology.
I tend to come at this more from a hardware perspective because of my background. And I'm thinking, okay, I need to add AI. I'm going to the NXP site, I'm downloading their tools, or the ST site and downloading their tools. And that's my starting point. But I think Avijit is going to approach this from a different perspective, being from Wind. What do you think about that, Avijit? I mean, you're coming at it, the names you ticked off are all the big software houses. So are you coming at it from the opposite side?
No, actually, this is a great topic to talk about, because I think, look, AI today is born in the cloud because fundamentally it is a big data problem, right? And for that, massive amounts of storage, compute, and networking were needed, and a lot of data was needed. And the way AI significantly accelerated over the last 10 years was because cloud computing came about, and mobile computing came about, and social networks and the internet came about. And I'll explain why that is important. The internet led to a large corpus of data being available. Social networks led to a lot of signals, real-time signals, and a massive amount of data in terms of likes and statements and pictures and videos being available. And then cloud computing, mobile computing enabled that social data and all of those things to be basically transported into the cloud, and the cloud became the central repository. So now you had an aggregate, scalable storage and compute environment in which data could be stored and then analyzed and then reasoned upon, which was up until that point not possible. So that is what led to the significant acceleration. So really, AI got birthed in the cloud, but it will live and breathe at the edge. Today, we find that in the form of our mobile phones, where image recognition is happening and various kinds of other AI is happening in the phone, disconnected from the cloud. We also have examples of doorbells, in the consumer space, if you will, and smart speakers. But in the industrial context, right, you have autonomous driving vehicles, you have computer vision-based defect detection in manufacturing, and you have drones and you have robots that are able to perceive the environment and react to it. So edge AI is already real, and it is being implemented. So to your point on coming at it from which side of the spectrum, right? I think the technology was born in the cloud, it's being deployed at the edge and operationalized at the edge. But the challenge is the edge is resource constrained. It does not have that amount of compute or storage and networking or memory. And therefore, the important thing is to take those models and those capabilities and to compress them and compile them in a manner such that they can be executed in a power and performance envelope that is constrained at the edge. And this is where the silicon folks like NXP you mentioned and all the other silicon players are innovating. Because what they're doing is they used to make microprocessors and CPUs, right? NVIDIA brought in GPUs, but then there are TPUs and NPUs. But some of these things are now being added on the side of a CPU as an AI accelerator. But the next generation of silicon is actually incorporating that into the compute unit itself, the system on chip, if you will, right? And there are various configurations of this available in terms of depending on what problem you want to solve and what kind of math operation you need to carry out, you may need just a CPU. If you think about it, Intel is the most widely deployed silicon, and it's principally CPUs. And a lot of AI and machine learning can actually be done using the kind of math that a CPU is really good at, typically machine learning operations. It's when you get into generative AI and you need to do matrix math of the nature that is needed for large language models with vector embeddings and RAG, that's when the GPU is purpose-built for it. But a TPU is really good for tensor math, and an NPU is really good for neural math, right? So the point is this, that the silicon folks are going to innovate, and on top of that, there need to be the right runtimes and frameworks to enable the AI that's birthed in the cloud to run efficiently at the edge. And so we as Wind River are really looking to solve this problem for our customers, because exactly to your point, Rich, today when you want to do something, you go to the NXP site, you download stuff, you get a board, and you start working with it. But your customer comes and says, I've chosen a different silicon. Now you need to go to that site and download their tools and their frameworks and their libraries and their operating system and do it. Now, if you try to scale this out, you have 11 different SoC providers, 11 different frameworks and tooling, and it becomes extremely complex and costly for you to do it. So the way to solve that problem is to have a common layer. And the history of computing shows that that is the convergence that always happens. Whether in the mainframe, it became IBM and Unisys, right, for banks and governments to adopt computing at large scale. Then in PCs, it became Windows and Mac for small businesses to adopt computing and applications, right? In mobile, it was iOS and Android. In cloud, it became Azure and AWS and maybe GCP. Same thing at the edge, but it's different in the sense that it's all either a real-time operating system or Linux, and it's open source, right? And so our job at Wind River is to take that and build a common operating layer that essentially abstracts or at least allows huge amount of reusability across silicon families and silicon architecture. So we are building the organizing layer that can enable embedded developers to build on x86, ARM, and RISC-V, and to be able to develop across various silicon families so that they can focus on the application layer on containerizing applications, on using different large language models and AI techniques in the cloud to build the AI, and then to compress and compile it to deploy it at the edge. Because we want them to focus on those higher level capabilities, which eventually solve the customer problem. Today, even buying patterns, like, people start off with saying, I'm going to buy a Qualcomm chip, and then I'm going to build a solution on top of that. It's completely upside down. You have to talk about what problem you're going to solve, and then figure out what data you need, what AI you need, and then choose the right silicon that can make that AI run in the most power and performance efficient manner, right? And that changing of the development model has to happen. So that's really what we're doing at Winterware. And I think we're uniquely positioned to be able to solve that for our customers across industries, across silicon families, across silicon architectures.
Yeah, and I think, it's funny you talk about this as being different, but it's actually going back to the way it used to be. Rich and I are old enough to remember a time when a company decided what software they wanted to run, and that dictated what hardware they bought, right? Because some accounting package or some CRM package or whatever only ran on IBM or only ran on DEC or only ran on whatever. And so you picked your solution first and your software, and that dictated the hardware. And then for a long time, with the rise of semiconductors and everything, it flipped around where you bought the hardware and wrote the software to work around your hardware. And now, to some extent, we're getting back to the solve it in software and figure out what hardware is needed to make that work. To your point, things can run on CPUs as well as a GPU if you don't need the things that GPUs do well. It can run on a CPU or an NPU if you don't need the things that require hardware acceleration. And a really good example is, there's a nuanced change that's happening even in the edge computing space that you're in by the push that's happening at the endpoint past you, right? There's a ton of AI now that's being implemented using DSP properties. Yep. Well, the ARM architecture, M4 and above, all have DSP extensions in the regular instruction set. So without any special hardware, any special acceleration, any special anything, some stuff that's happening on the endpoint product can be pre-processed, allowing the edge computing to do more of what it couldn't do without the cloud before, because your problem becomes a little bit simpler to solve, right? Yep. And so your space is being affected by what's happening on both ends, as well as changes in bandwidth availability. The stuff you're in is incredibly exciting to see how the world around it is influencing what you do in that industry.
Absolutely. Absolutely.
Okay, gents, I think we can put a bow on this one. This is where I want to take this, and I think we're at the point where we're all agreeing with each other, so we should probably stop here.
You and I agree, Rich? Wow, that's not how this whole podcast started. It started because we didn't agree on most things.
Well, we agree with Avijit. We don't agree with each other.
That's fair enough. Fair enough.
Thank you very much, Avijit. I appreciate you taking the time.
Yeah, thanks for joining us.
Thank you, Rich, and thank you, Vincent. Great conversation.